opposite over hypotenuse.
Yes.
So just be
So
sine
called
and then angle.
sine of the angle as like the input to the
Yeah.
sine function.
And the
equals
opposite angle over the hypotenuse.
Opposite side. Opposite side. Side. Whenever we talk opposite, adjacent, or hypotenuse, all of those are sides.
Yeah.
Richard, we missed you yesterday. Well, I mean, I missed you. Your friends can say whatever they want, or your colleagues can say whatever they want to. All right. So today we are doing more with factoring, and I want you guys to get more comfortable with this and me do less guiding. So as we look at 34 here, and apparently Smart Ink can start it up again, which is really dumb because you're working, but you're not letting me slide. So when we look at like 12, right, there's a lot of ways to factor, well, not a lot. There's a few ways to factor 12. Right, like 1 and 12, and 2 and 6, and 3 and 4. But the complete factored form, I just won't let me scroll, is 2 times 2 times 3, because we break it down to the lowest values possible. So even if you factor it down to 4 and 3, 4 can be factored further.
Can you factor that down even farther?
2, 2, and 3? No, because
Yeah.
these are all primes. So that's the prime factorization.
Oh, so like no decimals.
You could do like
No, decimals don't count as like clean factors.
And also, so
prime
prime number is a number that can't be multiplied to create itself. No.
Prime number is a number that can only be multiplied
Yeah.
by itself in 1.
Okay.
Divide.
So like 7 wouldn't be a prime number.
No, 7 is a prime number.
Yeah, definitely.
I got something nice.
Okay, so like 10 is a
Steve,
prime
I got something nice.
It's not a prime.
Graph paper or something like that.
Okay.
So, when we talk about factoring things, we want to factor completely. What? Why? Why aren't you letting me do what I want to do?
Because it doesn't want you to.
Well, that's not helpful.
That's not helpful, son.
It's a dumb one.
That is not helpful. Alright, so look at 34. We want to completely factor these. So I want to give you guys time because I don't want to be like the guide. I will help you if you need, but I want you to just engage with these. You can do it on your own, or you can do it with partners. Try to work through A through D, and I will tell you one of these at least, okay, 2 of them are really special, but one of them is special in a way we haven't talked about yet.
Oh, goodness.
Goodness gracious.
That's bad.
I can go ahead and tell you it's D that we have, like, it's not more complicated, we just haven't done this yet.
Okay.
That is
D?
D is the weird one. So so guys, that shouldn't be a surprise with how CPM works. Normally the first couple in a multiple like step or multiple problem, I guess, the first few are familiar and the last one will be something that pushes you. Like that's the CPM style. So I'm going to give you probably 3 to 4 minutes unless you guys tell me that you finish early. But I'm also trying to clean my glasses, which is a struggle today for some reason.
Oh yeah, that makes sense.
B is a special type, but we'll deal with that. We talked about it yesterday. I gave you the name. I'll be impressed if you can remember the name.
No,
Probably
I
have
found you.
somewhere.
probably not because I wasn't here yet.
Chris, how do you know?
You could have watched the video.
Yeah, different squares.
Haha, Hunter wins.
Hunter won.
Hey Hunter, do you want a dum dum? Do you want a dum dum?
I would like a dumb
I would like a
I
dum
told you I'd be impressed.
Hunter's a dumb dumb.
No. Hunter cared enough to like look it up in your notes. Difference of squares. So since we can only have math counts on Thursday this week because we're missing a couple teachers in 7th grade for today, but I will try to get snacks by then. Why is B a difference of squares, Hunter?
She
Oh,
guessed.
I'm about to take that sucker back.
Hunter, put it in your
I guess you could say
Shh. Hang on, keep thinking about it for a second because I got to recalibrate because this is way off. Hunter, do you know?
Oh, it makes sense.
Wait, yeah, again, you guys should have textbooks out. I am not your only ability for a textbook.
Bang.
Yeah, I
I got
know.
yours.
Bang.
Stop it. You're not making it any better.
What a savage.
Do you remember why? What makes it the difference?
Oh yeah, I remember.
Squares?
So it was like
Shh, I'm asking Hunter.
No.
Because
How did you know? How did you remember today? Like, how did you figure out to flip
I
to that?
remember the term.
But why? What does it have or not have that you're noticing?
It doesn't have the.
We'll try Richner. Just because you weren't here, it's funny you just raised your hand. What do you think?
No, I mean, I just know it's square.
Well, what does that one not have?
It's a square.
It
Doesn't
doesn't
have the
have a
other.
B.
It
The
doesn't
BX.
have the BX, right? The B is 0, but then, and I'll help you through this one, but then I want to give you time for A, C, and D. This becomes 9M plus 1, 9M minus 1.
You like flip it, but then flip the sign in the middle.
That is why it's difference of squares. Your coefficient here is a perfect square. And your value out here is also a perfect square, but it's negative, so we have to break it apart into 1 positive, 1 negative, root, quote unquote. Because 1 is the root of 1. So engage with A, C, and D for a moment. Try to figure out how D is different than what we've done.
Oh.
And that's what 35 then works us through, is how are there different ways. So if you can't figure out how it's different, just do it how you're familiar with. But then that will guide us to, not right now. Take like a couple minutes to engage with them on your own. I want you guys to discuss. Don't give away anything. Don't tell people who dies at the end. In B?
Yeah.
We just did B. That's how we can do B, like, well, not the easiest. That's just how that one is done. We know it's a difference of squares because B is 0. The only thing that's happened, and we talked about this yesterday, the only thing that happened to that is the intensity changed, like the slope of the parabola, essentially the intensity of it, and it got shifted down, right? It got moved down 1. But the 81 coefficient just tightens up your parabola. And then the minus 1, go down 1.
By the way, who finished
Yeah,
on
negative
first?
11 and negative.
What?
Who
Negative
finished
10,
on
negative
the decimal first?
Well, I don't know if anybody actually made it all the way through the challenges. You were like the furthest last time I checked it.
I got to a bunch of boring.
Yeah, it was like asking you questions and you were having like right answers. Okay, we are turning that off.
No, you.
So the first one, can we just write square?
Can you just write what?
Square.
I hope
For A?
Oh,
Yeah, what's the like the thing, the answer and then square, rather than writing the same thing.
Oh, you tell me. Remember, mathematics is all about efficiency, right?
wait.
But again, you're kind of giving away who dies at the end of the
Yeah.
movie.
They
Yeah.
Everyone dies.
Yeah.
How is that so weird?
Because it's,
It's addable.
is there a movie where everyone dies? Well, there's that one where Will Smith's the last person alive.
There's that Star Wars.
They're like almost.
Everybody died.
Oh, it's finished.
You're talking about a
Rogue One.
There it is.
Guys, if you don't engage with this on your own, you're not having that learning experience.
Super easy.
So Thomas kind of let the cat out of the bag by saying, can I just on A say squared? Why, Thomas? What are you thinking?
3x.
Yeah, you got it.
3x plus, no, minus 2.
It's just the same thing.
And so it's the same thing.
It's the same thing. So this
Perfect. I was just wondering.
is what we call a perfect square trinomial. Okay, so what you're looking for, now
Yes.
check, like, I need you to see this pattern because it will make your life a lot easier as you work with quadratics. Perfect square. Perfect square. Now hang on. The root and the root multiplied together double. Right? So root of 9 is 3. Root of 4 is 2. Those multiplied together for your outer and your inner, that's why it doubles.
It could be.
So if you see
Wow.
perfect square, then you can check, does the middle term work out to be a perfect square trinomial? Hopefully it does. If not, it's a little goofy.
Oh yeah.
You don't do your work.
So we can just write 3x minus 2 squared. We already did B. We're going to capture this. Are we done with C that we can go ahead and do it, or do we want more time? So first we change our order, right, to fix that. And since I only see x squared, I'm going to assume that makes my life kind of easy with my x and x. But then what do? Somebody I haven't talked to yet today. Somebody else say what happened.
Levi.
Yeah, Levi.
Levi! Your classmates have volunteered here. Can you think of factors of 28 that will sum to negative 11?
Negative 7 and -4.
Sure, let's try it. Negative 4,
Perfect.
negative 7, perfect.
Pronounced
Super
perfection.
So, is there anything special about that guy?
No.
Yeah, I don't think so.
It switched up
It's
to
normal.
it switched to the value.
Well, yeah, they just wrote it out of order. They didn't really, change things. D, have we figured out why it's special yet?
No.
It's
Maybe.
Yeah, because you can't get it.
Wait, I think I might.
If I take it just how it is, like we've been doing, since 3 is prime, I'm going to guess like that. Right, Jacob, where do I go from there? Don't tell me what's special about it yet if you figured it out. But...
Good morning, Phoenix. Please pardon the interruption. For anyone that was looking
Well,
to do the
copy.
Kilbourne Middle School drama auditions,
Yeah, that's
the Kilbourne drama auditions
Yes.
for today
Drama's
have been
awesome.
canceled due
What?
to the instructor being ill.
Oh.
They do still plan to have auditions for Kilbourne drama on Thursday. Thank you.
I guess you could say they're causing.
There's no one in here in Kilburn.
I wonder if he's sick or if he's just being dramatic.
I said a joke at first.
Look,
Copyright
mine
strike.
was better.
You're demonetized.
I haven't ever been monetized.
All your revenue's going towards me now.
You know, I don't even get paid as much as a babysitter to do my job.
Wait,
Yeah, there's a bunch of funny memes that are like, okay, so teachers are just babysitters. Let's pay them.
well, yeah, you're teaching babies.
No, but like, if I got paid what babysitters get paid, or like even, like
Got
people in
paid what-
daycares,
Not paying how babysitters have it.
I make a lot of money.
Babysitting actually is really profitable.
What do you
It
mean?
is
You have to
very
be
profitable.
for like,
Jacob,
Like,
get us back on
2
track.
hours
Okay.
is like $55. Degree.
So, to get the 6, you'd have to have the 3 and 2, because that's like really the only way you can find 6.
Okay. So then I can just
Except it has to
try.
be a certain way.
yeah,
I can try that.
To get the 9n, it would have to multiply
Ah.
the 3n.
and you
2.
just get
So if we play out this option, sorry, not 3, but just n.
that. What you wouldn't
That
get.
option wouldn't work. The top one would.
This one doesn't work, right? 9n, 2 more n. I end up with 11n.
11.
Even though I get my 6, it does not work for my middle term. This is the only way that works, but you know what's special?
What?
Yes,
I think so.
Was it that the coefficients of the n are different for this one?
What do you mean different? They're always different.
Yeah.
No, I mean
think
like
know.
the other ones, each of them have a pair because for A, both of the coefficients are 3 and 3. For B, it's 9 and 9.
Oh, because there our coefficients were perfect squares, right? Our coefficients to n squared. Even 1 is a perfect square. Well, arguably, depends on who you ask. Thomas, what are you thinking you see here?
Another equation.
What do you mean another equation?
Another answer.
Well, okay.
N plus 1 multiplied by 3n plus 6.
You're right, but you're still not where I'm looking for us to be.
Is it like the top numbers?
They're all
The top
three.
numbers?
Three.
Wait.
Yes,
Maybe
I
it's
was
squared
about
plus
to
3.
Yeah, they're all multiples of 3.
You can change it like that.
Oh, that. Oh, I was
You can
waiting
just
for
factor out a 3 before you ever try to do any work.
Dang.
I
And
was
if I
waiting
factor
for
out
that.
my 3, then my trinomial becomes a whole lot easier to deal with. N, okay, I gotta make 2, so 2 and 1, I gotta make 3. Oh, it doesn't matter. A whole lot easier.
Surprise.
Because this 3, easy to deal with. This 2, easy to deal with. No matter where I put the 2 and the 1, it works. Because there's no coefficients to my n's in here now.
I see.
Wait, would you have to put all of it inside parentheses?
No, because remember, multiplication carries through. So even if this only quote-unquote multiplies by this, then that multiplies by that, and it carries through the problem. Now, you could, if you wanted to, nest parentheses, but you do not need to. Because if you nest the parentheses, this happens first, and then
you
the
just go
3
back to the
applies.
first.
It looks
Yeah.
like a surprise guy. Like he's really surprised. Like, super.
Mega surprise.
Like, he was just told he was talking.
That is not funny. I don't know where your sense of humor comes from.
Repressed.
Yes, I know. And then the parents across
So, okay.
they're holding up the sign.
So I was watching comedians in cars getting coffee. I promise we'll be back on task. So we already did 35 essentially. We're gonna do these problems here, and they should be kind of like quicker there. But he was interviewing this comedian, and of course they're all just like trying to make jokes the whole episode. He goes, you know when people say like, you should sit down for this? You know, like the whole like you're adopted thing. Like you should sit down for this. Have you ever fainted? Like, why should I sit down? No, I have never in my life fainted. I'm not concerned about sitting down before you deliver me by it. Okay, his delivery was better, but it's like, that expression is antiquated. It's like, who faints these days? Like, give me bad news, whatever, I'm staying. Alright, try out that strategy on any of these that you think it would work on. Try out that strategy.
Ooh, yay.
Now my question is, does it matter which way we factor it? Like, will that change what I find out about the zeros and the other information that the factor form tells me? So if the factor form up here originally then my zeros are -1 divided, or -3 divided by 3. So, I kind of asked two different questions at the same time, because I know some of you guys go one way and some of you go the other way. So, I asked you first, figure out which of those could work using that special method where we factor out a common factor first. And then I also asked, but does it matter if we factor out the common factor first? So if I don't factor out the 3, right, my 3 is still in here and I could still factor it out, my 0 here, opposite of the constant, divide by the coefficient, or just set that equal to 0 and do the algebra. -3/3. My 0 here, what would make this 0? Well, that's easy. -2 would make this 0. -2. When I look up at the factored form that we did, completely factored, did it change what zeros I get? So the zeros that I keep referencing, you don't need to know these yet, but by the time you need to know them, I'm hoping you're like, oh yeah, we already got this. The zeros, where it crosses the x-axis, so here and here, right now from this, we said are -1 and -2. Well, they're the same thing up there in my completely factor form we just did. So whether you completely factor out or not doesn't change what you get, but it does change how easy it is to get there. So which of these would work using that special strategy? So I think 3. Yeah, I triple I, right? I. So here we can factor out a 2, which still leaves us with 6t squared minus 5t plus 1. But now that plus 1 should make things easy, because I know that my second terms in the binomials have to be 1s. What about here? We could factor out 5, so this becomes 5, 2x squared. Well, that 2 could only go in one of the binomials. 5x on 3, that's prime, so it's probably going to make my life a little easier to determine those values since I have less to choose from. I could only do 1 and 3 or 3 and 1 right in those binomials. Chris?
Can you do the rest of triple I?
Yeah. So this, I gotta carry the 5 on through, right? So I've seen people forget that. They factor it out and then they leave it. So 2 has to go somewhere. So I normally just give my first one the number if I don't know where it goes. Then I gotta make -3. So I gotta use -1 and +3, or -3 and +1, right? But then I have 2 options of where they go, so I really have 4 options here. -1, -3, +1, +3, -1, -3, +1, +1. I have all those options.
It carries out.
Sorry, what was that, Nib?
Does it matter which one we use?
It depends on if it's going to matter. Here, yes, because this coefficient. That coefficient is only going to apply to the value here, whereas this inner multiplication only has a coefficient of 1, so it doesn't get impacted.
So it should
So
be the one.
then you think.
So the one should be okay.
Then you think. We have an argument, right? A positive and a negative, they're going to fight against each other. One of these is positive, one of these is negative. Which needs to be stronger? Gentlemen?
The negative one.
The positive.
You fool.
Positive
But
needs
it's
to be
negative
stronger. Forget about that. When we add, when we look at the outer and the inner,
Oh,
the positive has to be
Yes,
stronger.
you fool.
Okay.
So, now this doesn't always work 100%, which is why we use technology when we can. But I assume that because the positive needs to be stronger, I put the positive where it's going to pick up extra strength. So then, if I do positive 3, I have 6x. I went beyond where I want to be, but then that's negative 1 and brings us back down to the 5. Complete factor form of quadratics, Mr. Smith.
Oh, what?
Now, I is actually harder because the 6t leaves you with options. So even with the 2 carrying, I could have 3t, 2t, or 6t, 1t. So we have to play with this a bit more. Normal, and we're not like, you don't have to get all of this because you asked to see I figured I'd come back to this.
I Captain.
Negative 5 is not that dramatic. Like, it's not that big of a number, right? Even though it's negative, we're just talking about how far away from 0. So if this was really big, I would probably think I'd have a 6 and a 1 for my coefficients. But because it's close to 0, I'm going to guess I probably have 3 and 2, that they're going to be similar to each other. And we've got some other strategies that we can use that we'll keep layering on here as we go. But then I need factors. Oh, well, 1. Okay, so how do I need to make negative 5. Oh, negative 1, negative 1.
Look at that.
Look at that.
I am looking at that.
Do you see that?
Look at that.
Is that a
No,
joke?
I that. Because there
I don't. I don't get it.
So many good
It's, my jokes aren't meant to be gotten.
But I would be I, not C. I can't see where you're going with this.
Listen, it was in letter C of that question.
You're worse than
I don't understand it.
Can we move on?
Exactly, we were doing that.
You gotta get letter 3.
Can we move on?
Use
your
your
brain.
go back to
Use
3.
your last.
I want
Alright.
2 to understand.
Young man.
Look at 37.
Going from.
0 talking for 3 minutes. I want to see if we can even do this. I'm going to put a 180-second timer up on the TV. 0 talking for 3 minutes, okay?
We wager don't.
No, because you already broke it. Try 37 on your own. then, when the 1 minute is up, if you are confident enough in your solution that you would like to come show it, the opportunity is open. Number 1, A. And if you would like to try the 8th grade argument of why do we need to do this, don't do it. Try it exactly how they sit. Don't factor out a common factor first. You'll be doing this for a lot longer than we are. It's not a thing that you have to do. It's a strategy that makes life easier. Yeah.
I think it makes it harder because I don't know where to do from. So I got 5. It means x squared 3x minus 9.
Minus
And
9.
Not my. That's a 4. I have bad handwriting.
That's why you don't know what to do. We had this issue on one of your assessments, too.
We did.
I told you, dude, you couldn't even read your own handwriting. Clean it up and look at where we are now.
No, that's not where I'm wrong is I don't know what to do from there.
Nid, come up. You volunteered for this, right?
Yeah. I don't
Go for it.
All right, so knowing that that's a 4, not a 9, are you coming?
Oh. So we coming around.
So here's the thing. When we factor out the common factor, we have a lot less options now. When I set up my binomials, the first values have to just be x and x, because we can only have a coefficient of 1. By the way, I told one of my friends I don't trust people that make x's like that.
Can you please stay on the side? Please. Looks like a K. Looks like a fucking shuriken. That is
Hey,
not
don't gang up on Didn't. I'm allowed to talk smack because I'm the teacher.
Yeah. Can we smack talk?
No, like, it does concern me that at some point somebody might not recognize what you're making if you're working
That is
fast.
most definitely a K.
So, when you think about making -4 as the product, that does not produce -4.
That produces -5. Do you know how to grow plants?
Like,
Not very good at producing.
Ah, there we go. A little copy down wrong. So, when you thought about factors of -4, that then sum to +3. So what we're doing again, if you need to set up a strategy for like, wait, I'm lost,
Do the diamond thing.
do the diamond, right? What we're looking for is -4 and 3. So if I'm trying to make -4 and +3, okay, 1 positive, 1 negative, my positive has to be stronger, so okay, 3 and 1, no, that doesn't work, that doesn't sum right, let's try, oh, it's 4 and 1, that's okay. And then you're good. Like, if you're trying to think through what works and what doesn't, or like Nidden accidentally tried 5, I think you just looked at the wrong part of his paper, yeah, that is absolutely your solution. Then, again, just to keep over-teaching, your zeros are when x equals +1 or x equals -4. That is where your parabola will cross the x-axis. You want to do 2?
Yeah, I don't know if I got it right.
Sorry, I was talking to Jacob. He had his hand up longer. You just can't see him when you're looking forward. So, all right, do B. Okay.
Man, that hurt.
Careful. You have computer and liquid, and I just be careful.
I actually just brought an empty laptop case.
No, you didn't.
Yeah, I did. Feel it.
Okay.
Oh, by the way, Mr. Fraze wanted me to give you a hard time about your music is really good, but you should try to play Go because it'll challenge you just like music did when you first started out.
No.
Yeah. And then we were talking about how oftentimes smart kids shy away from things that are extra difficult because they're not used to things being difficult.
Jacob bullies me mentally when I play.
Don't play Jacob.
If you don't play Jake,
What
if
did
you
you
play
say?
Nin, then you die either
I
way.
didn't forget anything.
No, play like a second grader, dude.
They didn't
No.
stop playing.
Play me. You're probably better than me. I'm not very good.
I'm probably like the best player in the club so
Nah, Nid is
far.
the best
He
player.
probably played.
No, the teacher is the best player.
Okay, that doesn't count. Devin doesn't count.
Yes,
I
it
guarantee
You know,
Jacob's better
I've
than
beaten
me.
Nidden and I've beaten.
Is that completely factored, or are you still up there to yell at Satya?
I'm pretty sure that's completely it.
Wait, that's
That's what
completely
I-
factored.
So check your product, check your sum. Do we produce -15?
Wait, what?
Do we sum -2? Yes.
Which problem?
This is
B.
B.
Notice it's not a quadratic, it's actually a cubic. So since it starts as a cubic, and everything has x's, although that's to the power of 1, doesn't matter, I can factor out an x before I ever start. trying to factor a cubic without factoring out a common factor, or even just the x,
When you
is
have
really hard. Like, say this then had like plus 15 or something like that.
Oh,
Even though I'd still have a common factor of 3,
What?
if I can't take out the x, this gets really complicated.
What?
You'd have to do like a 3D.
Yeah, you have to.
So,
You have to be like,
does this
ugh.
does this make sense?
Yes.
No.
Why the no?
So he's not here. Who's not here?
And literally anything.
So, did you watch the class video from yesterday?
No, I
Did you do
didn't,
anything to
because
catch
I
up?
forgot that we had
Oh.
that.
So, once you do that, then let's talk, and if you're still confused, you're missing a day of content, dude. So we gotta catch you up on that.
You missed the daily
Hey.
upload.
So, Chris, just let go of your stress right now. You should be behind. You missed a day.
I felt like that when we were doing
Stop. You're all a little bit overwhelming sometimes. Just so you get it. Like, you're all, like, a little. So, Chris, you're allowed to be stressed, but let go of it for now, because you're supposed to be behind. You missed a day. That happens. We gotta catch you up. D, what's the common factor out that we can do? Oh, come on. What's common in D? The Y. I didn't even make a joke about because I asked you.
Why did you want us to know? I don't see why that's important.
I don't
See?
see why.
I didn't do it, and Satya wouldn't disappoint.
There's a why. There's a why.
So, the x squared makes my life easy because I know I'll just have x and x. So, but if you need the reminder, what we're doing here is working backwards of FOIL. We're thinking through that the first has to multiply by the first. Chris, I'm doing a little bit of reteaching to help you out.
Yay.
The first also multiplies by the second over here, which is why we say outside.
So five.
Right? FO. Then the insides multiply to each other. And also the lefts. So you could just do a distribution of ba-dum, 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 ba-dum. But that's a bit more complicated to keep track of than having, like, did I do my first? Did I do my outsides? Did I do my insides? Did I do my lefts? So then we are trying to produce, and Chris, you might want to go backwards since we did a lot with this yesterday with the diamond method. Once I get a coefficient of 1 here, all I need to do actually is set up my diamond and say, I need to produce -10. I need to sum to -3. What factors of -10 can do that? Well, okay, 1's positive, 1's negative. I know that immediately because I'm producing a negative.
-5.
5 and 2 have a difference of 3. So 5, 2, that works. Check it. X squared, yes. -5x, positive 2x makes -3x. Good. -10, good. Cool. So that doesn't need to all make sense right now. Yeah, but it makes more. Now, if this has a coefficient, this is a bit trickier, and there's a math notes box in your book that walks through that. We don't really have enough time to walk back through that right now. What page was that? You guys, it was like 2 something. We had it open yesterday. And I think it's actually on this lesson.
227.
227.
Guessed it.
Lucky, baby. If you get it,
All right.
why would you?
Closed set. So take a moment and just read this.
Read what?
The information here about closed set. Jacob, I don't want to have to take books away. Can you define for me what a closed set is?
Without reading.
Who can paraphrase what a closed set is? Hans?
Well, if it's like you have it under a certain addition, subtraction, multiplication, division, and if it's a closed set, then it'll always end up as a whole number. Will always end up.
Way too detailed.
Can I
Way too
add?
detailed.
I'll just tell it forward.
No, you're good. Everything you said was true, but way too detailed. I need to simplify it. Lauren?
You take two numbers that are like the same kind of number, like integers or whole numbers. When you
Still
do
way too.
something-
You're,
Forwards.
Why
Ned.
would it just
Whole numbers under addition.
Now you're being specific about whole numbers, because closed sets isn't specific to whole numbers. Satya, give it a shot.
Whole numbers.
Nope.
Okay.
Operation. Okay, here's how you define closed set. Operation, whatever you're doing, input type, same output type.
Got it, robot.
That's it. Whether it's a rational number input, rational number output. Integer input, integer output. Whole number input, whole number output. So closed sets, whatever you put in, and this is still a whole lot of words, whatever you are putting in, you get the same type of thing out. Gentlemen, quit playing footsie. Come on. So if I put in positive numbers to addition, I get out positive numbers. If I put positive numbers into multiplication, I get a positive number out. If I put integers into multiplication involving positives and negatives, I'll get an integer out. So closed sets, or whatever type of thing I put in, is what I get out.
Wait.
Yes. So like subtraction of positives is not a closed set. Like whole numbers under subtract, I don't always get a whole number out. 5 minus 7, I don't get a whole number back.
Would
It's
2.5
broken.
for 2.5 not be a whole set?
Well, those are rationals. So we say, are rational numbers closed under addition? We would say, if I put rational numbers in any rationals I choose and add them, do I get a rational out?
You get a whole number. Yeah.
But is a whole number a rational?
Yes.
Yes.
So I can just say that anything is a closed set because all numbers are numbers.
Well, you could say that if I'm talking any number categorization, then sure, yeah. But that's purposeless.
Yeah,
So we use closed sets in like code writing, right? So if you are going to have a code making choices of should I do this, or how should I do this, or what should I carry out, giving it parameters such as keep the set closed, and actually certain codes are written like that, and that's where you get like rounded answers or approximate answers, things like that. So we are essentially out of time, but that's closed set, and I think
not going to knock away
so. This right here, Chris, is how we use the diamond method if we have a coefficient on the x squared. So what we do is we multiply the coefficient and the constant, and for what it's worth, we get 24x squared. Because we actually don't just multiply the coefficient, we use the x squared, but depending on your brain, you don't really need to care about the x squared. We get 24. Then we're trying to add to make 10. So I need to add somehow with these two to make 10, but multiply to make this 24. Well, 6 and 4 will work to make the 10, and 6 and 4 will work to make the 24. So then it works out. So that's where the diamond strategy is really useful if it's more complicated than just like an x squared something, like a 1x squared. Any coefficient on the x squared kind of messes stuff up.